Okay, we are back. Short, little, hopefully 5-minute video. The last thing you had to do for this week was watch this video on explaining the algorithm for converting an NFA to a DFA, and it asked you to do one problem. Okay, I guess I just got lazy and just wanted to assign a problem from the book instead of making my own. And there was only one NFA in the book, and it's kind of a lame one. Here it is. It was the one on page 557, which was the what I said to do. And yeah, that's because Gossip doesn't really investigate NFAs properly and even explain exactly how they work or give the algorithm. So I thought that was worth doing in our case. Anyway, this wasn't even like a real. This was kind of a lame one because there was no accept state, so I told you to modify it slightly by making Z an accept state. Okay, so here's an NFA. We're going to convert this to a DFA. First, let's notice where does the non-determinism lay, one of those two. Well, here we go. We see, first of all, that there's this lambda transition, so that I'm never really in the start state. I'm always in the start state sort of and X. And I guess from Y, there's no rule for what to do when there's an A. So that's kind of non-deterministic. Also from Z, there are no rules at all. And from X, there are two things to do when we read an A. Okay, so I think this one's going to be kind of easy. And here we're also going to see in this case, it's going to be a huge difference between following the strict Powerset algorithm and the more relaxed Powerset algorithm. The strict Powerset algorithm would now say to construct a new state for every subset of states in your NFA. But I really don't want to do that because there are 4 states, and suddenly that would require me making 16 states. And I don't want to do that because almost all of them are going to be useless and would get sort of pruned at the end. And therefore, I'm going to do the more casual approach where we just make the states as we need them. Okay, and for that we have to be maybe a little bit smarter or more careful or something, but it's just going to be better. So here we go. We start in state S, but do we really start in state S? No, we don't. We start in S and X combined. And so my first state is going to be the state in my DFA, which is associated with the subset of states SX. And that's going to be my start state. And then, what do I do when I am in this state if I read a B? Well, yeah, let's do B first, actually. So if I'm in X and I read a B, there's no rule, so I don't go anywhere. But if I'm in S and I read a B, I go to Y. I'm going to go to Y. So I need a Y state, so I don't know, I'll just throw that down here. And I will add a rule that says if we are in S and X and we read a B, we should go to Y. Good. What about if we read an A? Well, if we read an A from S, we're going to go to Y, but if we read an A from X, we're going to go to Y and Z, which means I need to create the state Y and Z, and that's going to be an accept state because ending in Y and Z means one of your branches ended in Z. So there we go. So this is going to be A. Okay. So let me just double check that. If I'm in S and I read an A, I go to Y, and if I'm in X and I read an A, I go to Y and Z. So surely there I am. Okay, we continue. What if I am in Y and Z and I read an A? Well, if I'm in Y and Z and I read an A, from Y I die upon reading an A, because there's no rule for what to do, and Z as well. There are no rules at all coming out of Z. So I do need the empty set state. And there it is, and that is what should happen when I read an A coming out of the YZ state. Okay, what if I read a B coming out of the Y, Z state? Well, if I am, again in Z there are no rules, but in Y if I read a B I go to just Z. So that indicates that I need a just Z state, which looks like that, and it will also be an except state, and if I'm in Y, Z, and I read a B, I should go there. But, what about now Z? If I'm in Z and I read anything, I'm going to go to the empty set state, to the garbage state, is what I called in a previous video, or the black hole state, is what Gossett calls it. Any string that entering state Z with characters left is going to eventually die because there are no rules for what to do when you are in Z with characters left to read. So we go to here, and of course in here we need to just stay there dead forever. Okay, I think there's one sort of open path to go, which is here. What do I do if I'm in Y, just Y, and I read an A? Oh, nothing. I go to the black hole state. And what do I do if I read an A? And what if I read a B? I go to just Z. And now I am done. And, okay, not pausing to check this or anything, because I just don't want to. I believe that this is just correct. I have my start state, I have two except states, and I have a transition arrow for both letters of my alphabet for every single one of these states. And as I've explored every single path, assuming I've done this correctly, there's nothing else to talk about. And notice that I used only 5 out of the 16 subsets. And so this was considerably more efficient than making all 16. So I think this is kind of the superior algorithm. But okay, there it is. And hopefully I did that right. Goodbye.